The definition of isolation really centers around high voltage.
Isolation is the ability to separate energy domains. The easiest way to achieve isolation is to use physical distance between the voltage domains. With isolated power modules, we are trying to achieve the highest possible power density and shrink solution size, so you need to come up with different ways to manage the electric fields that come up with those very high voltages.
And that's what we're enabling with IsoShield. The biggest challenges that isolation introduces is the trade-off between safety, which is the fundamental purpose of isolation, and all of the requirements from these new systems. The world is going to higher voltages, and semiconductors specifically. You see it in data centers now going to higher voltages. You see it in industrial with grid, battery energy storage systems and solar installations. You have to keep the solution larger in order to keep the high voltage isolation and safety in mind, while also trying to shrink it in order to integrate more and more of these into a system. IsoShield is a new transformer technology enabled through our packaging capabilities that allows you to integrate a transformer, very high efficiency, very small, inside of our package. And we use that transformer both to achieve safety for isolation, but also to transfer power across the isolation barrier with very high efficiency and very good performance.
And doing that means that your packaging technology needs to be extremely advanced. Every single interface within the device needs to be well controlled and well engineered to manage those very high electric fields in a smaller and smaller solution.
We also had to develop new technologies in the architectures inside the package, the topologies that we use in the overall system. I also believe that the size and the power density is very fundamental to our customer requirements. And in this case, we're able to achieve 3x higher power density than competing solutions.
Not only are these components 3 times smaller than the traditional discrete approach of building an isolated bias solution in a design, they are 40% smaller than any other available module that's in the market today. The speed at which innovation in electronic design is accelerating, you need to take every single advantage you have.
And you can imagine an electric vehicle, more and more features, more and more capabilities in every car year to year.
I think these isolated power modules and the way we're building them with more advanced techniques, we're only just getting started.
And TI is uniquely positioned to invest in power modules because we control the entire semiconductor design phases. Process, package, circuits, test, all of it is under one roof.
When you do something at scale in a semiconductor chip factory, your costs go down. And the control that we can achieve in these factories also helps us to go and achieve the highest possible power density, the best system robustness, and to have very reliable products.
And if you just imagine taking a capability and having 3x better power density than anything else that's out there, that's hard. And it requires a lot of innovation, a lot of persistence, a lot of problem solving, and a lot of technology development. And we're not done yet. We're just getting started.